Okay, in this session, let us see a few more problems in Z transforms. While solving these problems, we'll try to find out what are the different properties which we can use in the solution of these type of problems. Let's start with the question number 15. Delta of n minus k is greater than 0. Okay. Now let us see how to solve this. Let us first write down what is x of z. Okay. X of z is given by the formula summation n is equal to minus infinity to plus infinity x of n z to the power of minus n. So this is the Z transform for us. Now for us it is given that this is the delta function. So n is equal to 0 to infinity delta of n minus k z to the power of minus n. So if you look at this type of x of n, we remember that this is a time shifting property. Let us first recollect what is time shifting property and then try to solve this. Okay. So what is time shifting property? Time shifting property for us says the Z transform of x of n plus or minus k. So this n is shifted by plus or minus k, that will be given by z plus or minus k x of z. Okay. So the time shifting, this is the formula. Let us use this formula because for us here it is delta of n minus k. So let us use this formula here. Using that formula, okay, let us use this property now. Let us put this here, use this formula. So what will be our x of z for us here? Okay, you can get this as z of plus or minus k and then summation n is equal to 0 to infinity. Here plus or minus k is for us, this is negative. So we can write this as minus k. Okay, this is z minus k and then this is delta of n. And this exists only at one point. So this will be equal to z of minus k, z1 plus 0 plus 0 plus 0 plus so on. So this will be equal to z to the power of minus k. So what is ROC of this? The ROC of this is entire z plane, okay, except when z is equal to 0, because when z is equal to this do not converge. So this is the entire z plane except z is equal to 0. So what is it we have done? Looking at the problem, we have identified which property we have to use. So we have used this time shifting property. From the time shifting property, we got the answer. And then ROC we have defined. Using this, you can find out what is the ROC for this. So ROC for this is entire z plane except z is equal to 0. Let us see the question number 16, delta of n plus k. Okay, where k is less than 0. So let us see. The again almost looks a little similar to what we have done earlier, but we are discussing this problem also so that we can differentiate the ROCs for those two Z terms. Let us do this. Again, what is that? We have to calculate x of z. The formula for x of z is n is equal to minus infinity to plus infinity x of n z to the power of minus n. For us, this is equal to n is equal to 0 to infinity, okay, delta of n plus k, okay, z to the power of minus n. As you see here, x of n is shifted here. So this, if you can call this as x of n, then this is a shifted function, isn't it? So shifted by a certain function. So I can use time shifting property. Let us say using time shifting property, I can write this x of z is equal to, this is plus here, so this will be z to the power of k, 1 plus 0 plus so on, okay, so on. So this I can get it as z to the power of k. So x of z is z to the power of k for us. So what is the ROC for this? ROC will be entire z plane except z is equal to infinity. So here the ROC is entire z plane except z is equal to infinity, whereas in the previous case where we have taken delta of n minus k, it was entire z plane again but except z is equal to 0. So this is how you have to calculate the ROCs for both these functions. Okay, let us see the 17th question. 17th question is x of n is cos omega n u of n. That means this is equal to cos omega n when n is greater than or equal to 0. So let us see this. So let us find out let us calculate Z transform for this. So what is cos omega n for us? We know cos omega n can be written as e to the power of j omega n plus e to the power of minus j omega n by 2. This formula we all know. So let us use this here. So let us write down what is the formula first. So the formula for us is x of z is equal to summation n is equal to minus infinity to plus infinity x of n z to the power of minus n. So this I can write as, because this is a uniside function, I can write this as n is equal to 0 to infinity cos omega n z to the power of minus n. Okay, let us now put what is cos omega n for us? Let us write this in terms of e to the power of j omega n and see what will be the answer. Okay, let us try this. It's a little lengthy. So what we'll do this. So let us write down here x of z is equal to, now it is summation n is equal to 0 to infinity. I can write this as e to the power of j omega n, this formula, plus e to the power of minus j omega n. Okay, this half I will take it out here. So I can write this as half here. So then this will be equal to z to the power of minus n. So we have to find out the z transform for this type of combination. Let us split this into 2 now. So I can write this as half, okay, summation n is equal to 0 to infinity. Let us take out n common here. So that will be equal to e to the power of j omega z to the power of minus 1 n, we have taken that common, plus here e to the power of minus j omega z to the power of minus 1 whole to the power of n. Okay, now this is what we got. Now what we will do is, because the summation of both here, so we can put a square bracket, a flower bracket here. You will break this into 2 parts again and find out what is the answer. So what I will do is, let us write this here. Now let us put down this here. So what is x of z for us now? X of z is equal to half. Okay. Now I will split these two into 2 parts. So this will be equal to n is equal to 0 to infinity e to the power of j omega z to the power of minus 1 whole to the power of n. Okay. This part we have put here, plus n is equal to 0 to infinity e to the power of minus j omega z to the power of minus 1 whole to the power of n. Okay. So this summation. Now if I look at this, I can expand this, I can get the answer. So this is half now for us. And how much is this? That will be equal to 1 by 1 minus e to the power of j omega z to the power of minus 1 plus 1 by 1 minus e to the power of minus j omega z to the power of minus 1. Let us take LCM of this and find out. So that will be equal to, let us retain half here. This will be 1 minus e to the power of minus j omega z to the power of minus 1 plus 1 minus e to the power of j omega z to the power of minus 1. Okay. Then product of these two, 1 minus e to the power of j omega z minus 1 into 1 minus e to the power of minus j omega z to the power of minus 1. Okay. Now let us add all this and see what is the answer. Now let us write this here. So that will be equal to x of z is equal to, okay, half. Let us see how much is this. So this is 1 plus 1, 2, okay. This is minus e to the power of j omega and this is minus e to the minus. So I will take minus common here. So let us take minus common. So this will be equal to e to the power of j omega, okay, plus e to the power of minus j omega, right. These two I have taken. So then this whole multiplied by z to the power of minus 1. Okay, that's on the numerator. Let us check out the denominator. Let us multiply that. That will be 1 minus e to the power of minus j omega z to the power of minus 1. Okay, minus e to the power of j omega z to the power of minus 1 plus z to the power of minus 2, okay, after the multiplication of this. Now, let us see what exactly I can put this on. So, this is half, okay, and 2 minus, and if you look at this, this is a cos omega, isn't it? So, but what is missing here? Half. So, it is e to the power of j omega plus e to the power of minus j omega by 2 is nothing but cos omega. So, I can write this as, okay, because denominator and numerator we have to put it to. So, this will be equal to 2 cos omega z to the power of minus 1, right, by, here also I can take z minus 1 common, okay, then this will be equal to e to the power of j omega plus e to the power of minus j omega plus z to the power of minus 2. Again, if you look at this, this is again a cosine here. So, I can write this as half 2 minus 2 cos omega z minus 1 divided by 1 minus z minus 1 into 2. Let us put 2 here. That will be equal to cos omega plus z to the power of minus 2. Okay. So, this is x of z. We can simplify this further. So, what I can do here is, let us take this, simplify this further. This is divided by 2. So, x of z I can write it here as, x of z can be written as 1 minus cos omega z to the power of minus 1, 1 minus cos z to the power of minus 1 divided by 1 minus 2z1 cos omega plus z to the power of minus 2. So, this is called divided by, now let us put, take this LCM as z square. So, what I will do is multiply and divide by z square, the whole one, 1 minus cos omega z minus 1 by 1 minus 2z minus 1 cos omega plus z to the power of minus 2. So, let us multiply this and divide by this. So, that will be z square minus z cos omega divided by z square minus 2z cos omega plus 1. So, I just rewrite this a little here. So, I can write this as z square minus z cos omega divided by 1 plus z square minus 2z cos omega. So, this is my x of z. Let us see the next problem, that is x of n is equal to sine of omega n u of n. That is, this x of n is nothing but equal to sine omega n for n is greater than or equal to 0. So, let us follow the steps again. So, what we know is, okay, we know sine omega n is equal to e to the power of j omega n minus e to the power of minus j omega n by 2j. So, let us put this in our z transform formula. So, what is z transform formula? X of z is given by summation, the general formula is minus into plus infinity, x of n z to the power of minus n. So, let us write this here. So, I can write this as n is equal to 0 to infinity, as is the here case here, sine omega n z to the power of minus n. Now, let us replace this with the formula which we have already seen here. So, I can write this as x of z is equal to summation n is equal to 0 to infinity, okay, e to the power of j omega n minus e to the power of minus j omega n z to the power of minus n, and this 2j I will take it out common. So, I will put it here. So, this is 1 by 2j. Now, again let us take this common and then find out what is the equivalent answer for this. So, let us again do the mathematics here. So, that is 1 by 2j, okay, summation n is equal to 0 to infinity, okay. So, this is e to the power of j omega, I am taking n common, okay, minus 1 whole to the power of n, okay, the first part is taken care. Then comes the second part, let us put a flower bracket here. Then second part is e to the power of minus j omega, okay, z to the power of minus 1 whole to the power of n, close the bracket, and this is what you will get. So, now if you look at this This is one part and this is one part. So let us take this here and then find out what is the final answer. So we have to again follow the steps. Let us go that side of the board and then write down here. So this I can write as, okay, x of z is equal to half j. Okay, let's break this into two parts as I have said. Break this into two parts as I have said. This is equal to summation n is equal to 0 to infinity e to the power of j omega z to the power of minus 1 whole to the power of n. So this is the first part. Then comes the second part, that is n is equal to 0 to infinity e to the power of minus j omega z to the power of minus 1 and n. Okay, so let us again see what is this now. Take the formula for this. So this is I can write as 1 by 2j. Okay, this is 1 by 2j. This is equal to 1 by 1 minus e to the power of j omega z to the power of minus 1 here, plus this is equal to this, and this negative sign I am putting it here because this is negative here. So that will be 1 by 1 minus e to the power of minus j omega z to the power of minus 1. Okay. So let us take out the LCM and then simplify this a little further. Okay. Let us continue this here. Let us put this here so that I can write it as equal to 1 by 2j. Let us take LCM here. That will be 1 minus e to the power of minus j omega z to the power of minus 1. Okay. This minus, okay, that will be 1 minus e to the power of j omega z to the power of minus 1. Okay, we can multiply this here, 1 minus e to the power of j omega z to the power of minus 1, 1 minus e to the power of minus j omega z to the power of minus 1. Let us take this correctly. So it is 1 by 2j. Okay, so this is getting cancelled. That will be equal to e to the power of j omega z to the power of minus 1 minus e to the power of minus j omega z to the power of minus 1, right? Then comes here 1 minus e to the power of minus j omega z to the power of minus 1 minus e to the power of j omega z to the power of minus 1, okay, plus z to the power of minus 2. To simplify this further, so this will become 1 by 2j. This I can take common z1 minus common here. This will be e to the power of j omega minus e to the power of minus j omega, okay, by, I can write this as 1 minus e to the power of j omega plus e to the power of minus j omega, okay, z to the power of minus 1 plus z square. Okay, so this will be the simplification. Further, as you understand here, if I multiply this and divide by 2j, what happens? I can write this as sin j omega function. Let us put it there. So I can write this as equal to 1 by 2j. Okay. So this I can actually multiply and divide by 2j. So I can write this as 2j z minus 1 sin omega here, because that is what is this. So divided by, again here this will be 1 minus, as you see here this is cos cosine, but you have to divide by 2. So this will become 2 cos omega z to the power of minus 1 plus z square. So divide this, so that will become z inverse sin omega divided by 1 minus 2z to the power of minus 1 cos omega plus z to the power of minus 2. Okay. So this is z to the power of minus 2. I just repeat here because there is a small error which we have made. I just make the correction. You can override this with my earlier things from this step. So as you see here, after multiplying, I get this e to the power of, we have taken this common, z minus plus z to the power of minus 2. That is what we have done here. So this also it is z to the power of minus 2 and minus 2. Now let us divide and multiply by z square as we have done earlier. So let us say this is equal to z square by z square, okay, and that will be equal to z. So this will be equal to z sin omega. I repeat this, okay, earlier we have rubbed, so repeating it, z sin omega divided by, okay, this will be z square minus 2z cos omega plus 1. So, this is my x of z. So, this is the x of z, z transform of a sinusoidal function. Let us see the next problem. Here x of n is, earlier we have seen with cosine function. Now, this cosine is multiplied by a certain factor r to the power of n. Let us see how exactly this problem can be solved. The same procedure will follow, but one extra term will be there, that is why r. So, we have to carefully solve this so that we can get the final answer correctly. Okay, let us do this now. Okay, let us go straight into the x of z. X of z is equal to n is equal to minus infinity plus of infinity x of n z to the power of minus n. Okay, but this is equal to r to the power of n cos omega n when n is greater than or equal to 0. So, the summation changes now. So, what is the summation change? The summation changes to n is equal to 0 to infinity r to the power of n cos omega n z to the power of minus n. Okay, let us put a bracket here. So, this we have to solve now. So, again we know what is cosine. Cosine function is equal to half of e to the power of j omega plus e to the power of minus j omega. So, let us put that here. So, what I will do is n is equal to 0 to infinity. Okay, I will take half outside, then this will be equal to r to the power of n e to the power of j omega plus e to the power of minus j omega z to the power of minus n. So, let us take again n common here. So, I can write this as half summation n is equal to 0 to infinity, okay, r e to the power of j omega z to the power of minus 1 whole to the power of n. So, we are taking care of the first term. Then we can look at the second term also. So, what is the second term here for us? That is, let us put a square bracket here. So, that will be equal to summation n is equal to 0 to infinity r e to the power of minus j omega z to the power of minus 1 whole to the power of n. So, we have two terms here. Now, let us write down here. So, I can write this as half of, okay. So, that will be equal to, summation will be equal to 1 minus r e to the power of j omega z to the power of minus 1 plus 1 by 1 minus r e to the power of minus j omega z minus 1. Okay. So, now we have to add these two now. So, let us do this addition here. So, I can write this as half of 1 minus r e to the power of minus j omega z to the power of minus 1 plus 1 minus r e to the power of j omega z to the power of minus 1, okay, divided by the product of these two. So, that will be equal to 1 minus r e to the power of j omega z to the power of minus 1 into 1 minus r e to the power of j omega z to the power of minus 1. Okay. Let us close this here. Let us just check what we have done correctly, isn't it? So, we have to take the LCM. So, this will be equal to 1 minus r e to the power of minus j omega z minus 1 plus, because this plus sign is here. So, this will be equal to 1 minus r to the power of j omega z minus 1. Then we are multiplying these two. So, that is 1 minus r e to the power of j omega z minus 1 into 1 minus r e to the power of minus j omega z minus 1. Let us see how, what will be the product of all this. So, let us write down this here. So, the x of z is equal to now for us, okay. So, that will be half of 2, okay, 2 minus I will take common, to r also I will take common, z minus 1 also is common. So, that will be equal to e to the power of j omega, this one, plus e to the power of minus j omega, that is the second one, okay. Then this divided by, okay, the denominator we can cross multiply this. So, this is what we will get here. So, that will be 1, okay, minus r e to the power of minus j omega z to the power of minus 1 minus r e to the power of j omega z to the power of minus 1 plus r square, okay, z to the power of minus 2. Okay, this is what we got for the multiplication. Let us just cross check this again. This term is 1, so we got this term. So this multiplied by this, we got this. Okay, this multiplied by this, we got this, and then plus this multiplied by this, we got this term. Okay, now let us simplify this further. So I can write down this, understanding that this is equal to half of, okay, 2 minus, this I can write in the form of a cosine function, provided there is a 2 in the denominator. So we add, divide and multiply by 2. So that will be equal to 2r z minus 1 cos omega, okay, divided by, this I can write in terms of r and z minus 1 taking out common. So that will be equal to e to the power of j omega, okay, plus e to the power of minus j omega minus z to the power of minus 2 into r square. So r square also will add here. Okay, so this is what we will get here. Now let us divide this by 2 here. So then numerator will become 1 minus r z to the power of minus 1 cos omega, okay, and this I can write as 1 minus, here what I will do is I will divide 2, so this will become cos, then I will multiply it by 2 here. Okay, so this will become 1 minus 2r z to the power of minus 1 cos omega plus r square z to the power of minus 2. Now what I will do is I will divide this and multiply by z square here. So this will become z square minus rz cos omega, okay, then this I can multiply, so this will be equal to z square minus 2rz cos omega plus r square. Okay, so this is we have multiplied. So this is z square minus 2rz cos omega plus r square, and this is again z square here minus rz cos omega. So this is my x of z. So this is the function z transform of a given function Rn into cos omega n. This is the z transform for that. So what is ROC for this? ROC is z greater than r here. So I can write down here ROC is z greater than r. So this is the region of convergence. Let us see the 20th problem. X of n is equal to r to the power of n sin omega n un. Okay, this problem is almost similar to what we have done earlier. So let us just quickly write down the final formula for this, because the steps are same except the fact that cosine is given by e to the power of j omega plus e to the power of minus j omega by 2, whereas sin omega is given by e to the power of j omega plus e to the power of minus e to the power of minus j omega by 2j. So except for this, you just put it here and then we will get the answer. So let us write down this. So this will be equal to r to the power of n sin omega n. This is x of n. So x of z I can write it as summation n is equal to 0 to infinity r to the power of n e to the power of j omega n minus e to the power of minus j omega n by 2j, okay, into z to the power of minus n. Again taking n common and all those things, I will get a final answer. X of z is equal to rz sin omega divided by r square plus z square minus 2rz cos omega. Okay, same thing you will get here, and the ROC is again z greater than r. If you compare this with the earlier formula, if you see the denominator is same in both the cases, whereas the numerator z square minus rz cosine cos omega was the z transform when I r to the power of n cos n omega. So here this is rz sin omega, so by r square plus z square minus 2rz cos omega. So this is the formula which you all should remember, and the ROC in fact is same in both the cases, that is Z is greater than R. So this is the Z transform for a sine. Now you can appreciate the similarities between what we have done in the previous 4 problems. First we have calculated the Z transform for a cosine function, then we have calculated the Z transform for a sine function, then we have calculated the product of r to the power of n and cosine function, then we have got a certain answer, and now finally we have done a problem which is r to the power of n multiplied by sine omega, you will get a Z transform. Now all these 4 formulas, there are certain similarities which you should appreciate and understand for a easy solutions of problems.